Okay, welcome to Bright Brain City Grass, where problems of mathematics are solved all the time. Okay, today we are having a nice challenge, which I call the Lambert W function challenge, which says 7 to the power of 2x equals to 5x. And the question says x is equals to what? So we are looking for the value of x in this challenge. So if you are new to this channel, you can click on the subscription button, and by the time you have done doing that, you can hit up the notification bell so that you get notified anytime I release videos, because in this channel I release videos or I drop videos all the time on mathematics. So let's see how we can resolve this. Okay, first of all, we can say solution. Then write the question, which says 7 to the power of 2x is equals to 5x. Okay, there's something you have to note. We are having 7 to the power of 2x equals to 5x. On this left hand side, we're having x as an exponential number, and on the right hand side, we're having x as a base number. So how can we resolve for this? Okay, resolving for this, I will simply tell you the rules we are going to use. We are going to use the Lambert W function in solving this, because it is only through the Lambert W function we can actually use to solve this. So if you are new to Lambert W function, I would advise you to watch from the beginning of this video to the end so that you can see the rules I'm going to apply using the Lambert W function. But before I use the Lambert W function, I'm going to apply some mathematical principles and laws. So let's see how we can resolve this. Okay, if I'm putting this, okay, the first thing I'm going to do, I can rewrite this again. Okay, remember from your rules of indices, if you're having a to the power of n is also equals to a to the power of n, open bracket, close bracket, to the power of what? M. Okay, applying these rules here, I can say 7 to the power of what? 2 x is equal to 5x. Okay, having done this, so the next thing we can do from here, 7 to the power of 2 is going to give us what? 49. So we're going to have 49 to the power of x is equals to 5x. Okay, we are still having a challenge with this exponent x. So what are we going to do? Okay, I will simply divide. Let me divide both sides by 4 to the power of x. Sorry, 49 to the power of x, 49 to the power of x. So if I should do that, this and this are going to go. So I'm left with 1 is equals to 5x all over 49 to the power of x. Okay? Now we're having 5x all over 49 to the power of x. So in other words, I can still remove this by putting this to the left hand side of the equation. So if I'm doing that, I'm going to have 1 all over 5 is equals to x all over 49 to the power of x. Okay, we are now having x in one side and a number without x at one side. So we are now having 1 all over 5 is equals to x all over 49 to the power of x. Okay, so what are we going to do from here? Some of us will say, let's cross multiply. So if we should cross multiply, we are returning back to our previous question. So what are we simply going to do from here? Okay, I'm going to apply one of the rules from lab reading. Let me wipe a little bit. One of the rules from log reading, which says if we're having exponential natural log of p is also equals to p. Okay, if I should apply this principle here, so I'm going to have 1 all over 5 is equals to x all over exponential natural log of 49 to the power of x. Okay, we are now having something new. We are now having 1 all over 5 equal x all over exponential to the natural log, or what we call the ln or ln 49 to the power of what? Of x. Okay, having done this, what then are we simply going to do? Okay, rewriting the whole of this, we can say 1 all over 5 is equals to, I'm going to apply a principle again from the same indices. Remember from indices rule, if you're having 1 all over a, is also equals to a to the power of minus 1. So if I should apply this principle here, I'm going to have x times exponential of the natural log of 49 to the power of minus x. So I'm now having this 1 all over 5 is equals to x times exponential ln 49 to the power of minus x. Okay, having done all this, we're going to have our 1 over 5 is equals to x times exponential of 49 to the power of minus 5. We're having the power minus x. So, from principle of logarithm, this can quickly come to the back. Sorry, indices. So, we're going to have 1 over 5 is equals to x times exponential of minus ln, so minus x ln 49. So this is our new form of the question. We're not having this. We're not having 1 all over 5 equals to x times exponential of minus x ln 49. Okay. Well, what then are we going to do from here? Remember? Okay, before I go further, let me just introduce the Lambert W function to you if you are new to it. And the Lambert W function says, if you're having a Lambert W function, if you're having x to the exponential of x is also equals to, if we should apply the Lambert W function, it's going to give us our x. So we are going to have our x because the Lambert W function is, if we have x exponential x, apply the Lambert W function is going to give us x. So, but at this junction, when we are having x exponential minus x ln 49, so this side is not yet equivalent to the exponent. So what are we simply going to do? We are going to multiply both sides of the equation with minus ln 49. So if we do that, we're going to have minus ln 49 times 1 all over 5 is equals to minus ln 49 times x times exponential minus x ln 49. Okay, we are now having, we multiply both sides, minus ln 49 times 1 over 5 equals to minus ln 49 times x times exponential minus x ln 49. Okay, if we should rearrange this, we are going to have minus ln 49 times 1 over 5 is equals to, rearranging this, we are going to have a minus x ln 49 times exponential minus x ln 49. Okay, we are now having this number equivalent to the exponential number. Okay, what are we simply going to do from here now? We are going to now apply the Lambert W function. But before we do that, we can rewrite this in the place of this, then write this in the place of this. So we can simply say minus x ln of 49 exponential minus x ln 49 equals to minus ln 49 times 1 all over 5. Okay, this is what I'm saying. Bring this here, still remains the same because we have an equality sign. Okay. What then is the next step? Okay, we are going to apply the Lambert W function rules direct. We are going to apply the rules direct. So we are going to have multiply both sides by Lambert W function by Lambert equals to Lambert W function. So we are having the Lambert W function. This W represents the Lambert W function. So if you apply Lambert W function, remember we said if we are taking the Lambert W function, or if we have x exponential x, taking the Lambert W function, x exponential x is equals to x. So if we should take this, we're having minus ln 49 exponential minus ln 49. So at this junction, we are going to have our minus x ln 49 equals to, if you take the Lambert W function, we're still going to have v as w, open bracket, minus ln 49 times 1 all over 5. Okay, in order for us to look for s, we can divide both sides by minus ln 49 minus ln 49 minus ln 49. So this and this will cancel off, this and this will cancel off. So we are left with what x. So our x is equal to Lambert W function of minus ln 49 times 1 all over 5 close bracket all over minus ln 49. Okay, so this is 5 and this is 5. So our final answer is x equals to Lambert W function ln minus ln 49 times 1 over 5 all over minus ln 49. So this is the value for x. So if you find this video interesting and useful, you can click on the subscription button if you have not done that, and hit up the notification bell so that you get notified anytime I release videos. Like what I said, we drop videos on mathematics all the time. And I would love to see you in our next video. God bless you and Jesus loves you. And also don't forget to hit up the thumbs up button. If God loves you, and bye for now.